This question, question 9, we have a particle of mass m. It's acted on by a force. The magnitude of this force is 2m over x to the power of 5. It's directed away from a fixed point O, going in this direction. And x is the distance of the particle from O. The particle starts from rest at a point which is the distance d from O. Let's say this distance here is d. Show that when x is equal to this root 3d, the speed is this. So dealing with distance and speed. So let's have a look. We have force is equal to m times acceleration. Our force is 2m over x to the power of 5. It's going in a positive y direction, we have it as positive here, is equal to ma. Dividing by m, we're going to get acceleration to be 2. I'll write it as x to the power of minus 5, and I'm going to have to integrate it in this question. So we're dealing with x instead of s here. And we're dealing with velocity, so v dv ds is the acceleration that we'll use in this question. Is equal to my acceleration to x to the minus 5. So I'll change my s just to x, and we get v dv is equal to 2x to the power of minus 5 dx, and then we can integrate and start solving. So it's acted on, it's starting from rest, so we just have our regular intervals, our 0 and v, and then distance wise it's starting at distance d from x, so that's the distance, from O, and it's traveling a distance of x, or it's in terms of x, so we have to have an x and a d here. So we're going to get v squared over 2. It's just going to be v squared over 2. 0 won't have any impact. Equal to, we're going to have 2x to the minus 4 over minus 4, which is 1 over, bringing the negative indice to the bottom, 1 over, it's going to be minus 1 over 2x to the power of 4. So we're going to have minus 1 over 2x to the power of 4 between x and d. Subbing in my values, I'm going to get v squared over 2 equals minus 1 over, putting x in, 2x to the power of 4. And then I'm going to get minus minus, I'm going to get plus 1 over 2d to the power of 4. Multiplying everything by 2, I'm going to get v squared is equal to, I'll just reverse the order to have the positive one first, 1 over d to the power of 4 minus 1 over x to the power of 4. So my velocity in terms of d and x, d being the starting point, is 1 over d to the power of 4 minus 1 over x to the power of 4. As to sub in a value, x is equal to root 3d. So we sub in that for x, root 3d. Might be easier just to sub it in here. Root 3d to the power of 4, root 3d to the power of 4 is going to be equal to root 3 to the power of 4 times d to the power of 4. So root 3 by root 3 is 3, and 3 3s are 9, so it's going to be 9d to the power of 4. So the velocity is going to be equal to, say we have to write the square root a few times, I'll just do a little bit of rough work here. 1 over d to the power of 4 minus 1 over 9 d to the power of 4. If we give them the same denominators, I can make the top and bottom a 9 on the left. So 9 minus 1 is going to be 8 over 9d to the power of 4. So velocity is going to be the square root of 8 over 9d to the power of 4. Just 9 minus 1 is 8 with the same denominators, which is equal to root 8 over root 9d to the power of 4. And the square root of 8 on your calculator is 2 root 2. And the square root of 9 is 3. And the square root of d to the power of 4 is d squared. 2 root 2 over 3d squared. 2 root 2 over 3d squared, and then show that the velocity of the particle tends to a limit of 1 over d squared. Here's my velocity. So you can see to get 1 over d squared, it's the square root of the first one. So why does this tend towards 0? Well, x is getting bigger and bigger and bigger, going in that direction. So x is tending towards infinity if it keeps going. And 1 over infinity would tend to 0. Therefore, do they call it terminal velocity? I'm not sure, but the max v, or v max, is going to be equal to the square root of 1 over d to the power of 4, which is 1 over d squared, which is what we were asked to show.